if one of the fragments, if it just moves vertically up, here half of the energy, 1/4 of energy I'll put it. How the other fragment must move not vertically down, it should move in a plane, because initially there was momentum along x-axis. Okay, fine. Final momentum along y-axis should be 0. So therefore now what is the equation you are going to write it? How the equations? So net force along x-axis 0. Initial momentum mu cos theta. Final momentum. That's all. Then net force. Momentum is conserved in any direction. Here just we are picking up x and y. 0 initially. So final momentum mv1, m1 v1 minus m2 v2. Okay. Then what is the? It's telling 1/4 of energy. You should write in this way. So how to predict that if one of the fragment, if you know how it moves, Unnati class. If one of the fragment, if one of the fragment, if you know in what direction it moves, the other fragment in what direction it moves, we can predict here. Where do it land also we can predict. So here it will go and land somewhere here. I think I'll draw the trajectory properly. So where do the trajectory will come like this. The other one will land here. Okay, no, so there are sameness. Even if it one of the fragment, if it moves like this, the other fragment has to move in this direction. Okay, that one. So you may get wide varieties of questions here. A student has to take help of this one. It may happen that both the fragments after explosion will move horizontally also. It may not to explosion need not occur always at highest point. It may occur here also. I just gave one of the examples. Now this is very important, sir. Energy release, what to do? It will be available as energy of the fragments here. I think conservation of momentum is very important. How to predict the path of the other fragment, both the center of mass, because if first fragment, where do it will land? It will land here, no? The second fragment, will it land here? No, it should land here. So what is the region? Here, second fragment will land. The first fragment will be here. Center of mass has to be here, no? If the center of mass has to be here means, so where the landing point of M2, we expect M2 to be here. And we'll expect M1 to be here. M2 cannot be here. Center of mass here, M1 and M2 cannot be here. So a student has to make a guess of all the available things. A good number of questions can be asked. So take help of all the basic things what you know.
Sir, after explosion, can they move in horizontally opposite direction, sir?
Yeah, they can move also in opposite direction. I'll bring one more situation. Anything, let them move in whatever direction they want. You apply conservation of linear momentum, that's all. Okay, I'll bring one more. It can happen. Let's keep it here. It can happen that this V1 let me adjust this. explosion occurs here, and after explosion M1 and M2. This can also happen, and the trajectory of this. So many possibilities are there. I think it's like just let me generalize it. We can't keep on draw the diagrams. So many possibilities are there. Altogether, momentum should be considered in all directions. So usually we prefer x and y, easy for us to analyze here. Okay, there's M2 and there's M1. It should not land here. No, it's going to land here. Then what is the expression? Here one third I'll take it, or total energy is converted. Total energy released is during explosion is converted into kinetic energy of fragments. So what are the equations we'll write here now? Apply conservation of momentum again. Here's what the explosion. It will explode here. So conservation of momentum. M1 mu cos theta equal to m2 v2 minus m1 v1. Then m by 2 u cos theta whole square plus c naught, no? One very simple explosion is internal force. During explosion, internal forces will act. Finish over. That is enough. That is only teacher should tell. Any possibilities can happen. So based on the conditions given, now you are going to write all the equations. Okay, this is very important. Can be asked in, because some projectile is mixed with center of mass, so all possibilities of asking. Instead of throwing horizontally, I may throw this explosive vertically. I may throw this explosively from the tower, from the inclined plane. So it's unlimited, no? Just carry on. There's nothing called like a should be asked like this only. There are several ways of testing a student.